All right, welcome back, everybody. Let's get started. Just to bring you up to speed, in our last video, we looked at the salaries, the global tech salaries data set. We did some EDA on it, made some visualizations. Let's go ahead and get a model trained here. In order to start that, I'm going to go ahead and add scikit-learn to my environment here. And I already had it. Okay, let's get some space. All right, first thing we're going to need to do is I'm going to go ahead and open up a new file for this just to have these separate. I'll go ahead and import pandas. And let's go ahead and import numpy and import scikit-learn as well. Let's go ahead and bring in our data set here. Let's see. Make sure we've got the right data set. All right, that all looks familiar to me. I'm going to go ahead and start with the salaries data set fresh. And let's go through and just go through the process of actually training the model here. I've got the data set. I'm going to let's go ahead and import our tools from scikit-learn. We'll go ahead and just run this as a linear regression here. There's other models that might be more appropriate, but let's just get this going. Linear regression. All right. First thing that I'm going to need to do is I will need to identify what the X and Y are going to be for my model. The X values refer to the features of the data set, which is going to be everything except for what we are training for, which in this case we're going to be using salary and USD as our target. So our features are going to be salaries, and then if we just do a drop, salary and USD, set X is equal to 1, that's going to give us all the columns except for salary and USD here. And I'm going to go through the process here, and you might have some thoughts on what we're doing, how we make this better, and we'll go back through and do that a little bit later. But I want to kind of get some real, kind of the real experience of going through, learning from the first model that we trained, how to improve it, and going back. All right, so from there I need to I need to split my data up into training data and test data. So I'm going to import from sklearn.model_selection. I'll import my train test split function. And then from here we can use some tuple unpacking. And y test equals train test split. X and Y in here. And let's go ahead and set our test size to 0.3. And I'm going to go ahead and give a random state of 18. Just in case you're using the same model, you want to check up against and make sure that you're getting the same answers as me. Okay, I've got my model split into training and test data. And let's go ahead and try to fit the model here. We'll go ahead and say linear model. I need to instantiate my model here. And we'll go ahead and call fit on it with X train and Y train. And first thing I notice here is I'm getting an error. Let's go ahead and see what it is. This could not convert string to float of MI. All right, well, let's go back and look at the data set here. And I can see that it's probably referring to this one, a mid-level experience level. Well, what's going on? What we're seeing here is our data set is, our model's unable to, turn a string of MI into what we would use in model training, which is numbers. It needs floats. It needs numbers. So we're going to use a method called one-hot encoding in order to make some of these values into data that we can train a model with. So let's go back. I'm going to insert these cells right here above where I split off my X and Y. So in order to do this, first thing I want to do is I want to identify all the categories that are going to fit this bill here, which are going to be experience level and employment type and job title and salary currency and employee residence, and let's see what else I've got over here. Company location, and company size. Okay. So those are my categorical features here. Pandas has a really handy tool called Get Dummies. And what that does is it takes our data set. We're going to pass in the data set. We're going to pass in the categorical features, like the names of the features that we need to turn into one hot encoded features. And it outputs a new data set for us that we can use. So we'll go ahead and import that. Let's see, we need from pandas, import get dummies. And we'll say salaries equals get dummies. We'll say salaries columns equals categorical features here. All right. And just to show what that's going to make our data set look like now, here is our new data set. And one more thing I want to do real quick. Go ahead and drop the first equals true. Yeah, it's not going to work now because I've already got that data set. Okay. So we can see now that rather than having a column of experience level, we've got 4 different columns: experience level entry, experience level executive, experience level mid, experience level senior. And so those are going to be the columns, and then whichever value it was, that value is now set to true. Anything that was categorical is going to be split out. And as you can see now, I've got quite the wide data set. It's 265 columns now. And we might do something a little bit later to try to pare that down. But as of now, we're going to go for it. I'll rerun these cells here. And let's go ahead and try to fit again. All right, I've got a model. And let's go ahead and test this model. See how good it is. Okay, my model has been trained. Now let's go ahead and evaluate this. Let's run some predictions. We'll go ahead and say predictions equals linear model dot predict. And we will pass in our X test. And then what I want to do now is I want to see were those predictions any good. So what I can do is I can just print out predictions minus Y test. And as I'm looking at this, this kind of gives us a list of all the predictions against the true values. And some of these are all right, you know, being off by the salary by about 1,800, not too bad. Some of these, though, are pretty terrible. By 24,000, 34,000, that's not great. Let's get a more succinct look at this. We're going to use a measurement called mean absolute error and root mean squared error here. Scikit-learn has these in its metrics module. Go ahead and import root mean squared error and mean absolute error. Our RMSE is going to equal, we'll say, root mean squared error of Y test and predictions. And we'll say MAE equals mean absolute error of Y test and predictions. And then we can just go ahead and print these out. Okay, so our root mean squared error, 127,000. So on average, our prediction is off by 127,000. But our mean absolute error shows 25,000, which is much better. Not great, but significantly better. What's happening here is root mean squared error. Right, so what we have going on with this model is our mean absolute error is not great. When the average value of these is going to be in the 150 to 200,000 range, being off by 25,000, somewhere between 10 and 15%, that's not too bad. But our root mean squared error here of 127,000, root mean squared error is a different way of calculating how accurate a regression model is. And this is a method that punishes outliers. Mean absolute error kind of brings them back to the middle. Either way, not very good. We can do better here. But at the same time, I also think that there are some things in this model that's causing it to perform better than it should. And let's go ahead and look at that, just from a kind of a logical standpoint. And this is one that it should be a dead giveaway, is that I know the salary, and I know the salary in USD is my target. And for the most part, these correlate 100%. And if it doesn't correlate 100%, it's very easy to figure out what the correlation actually is. So by that measure, and not only that, but in a real life scenario here, I'm not going to know what the salary is, but not what the salary is in USD. It's not like we're just waiting to figure out what the exchange rate is. If I don't know the salary, I don't know the salary in USD, and I'm not expected to know that at the time of prediction. So I'm going to go ahead and drop the salary category. In fact, let's just go ahead and make a list to be dropped. And we'll start off with salary. Let's see what else we want to drop here. Company location, and there's the employee location as well. Let's go ahead, restart this, because I want to look at the columns before I've done any encoding on them. No, that's not going to work. Let's restart it. And run to here. Okay. And let's move this to be dropped up a little bit higher. Okay, so we're going to drop salary. And salary currency, that's not really going to play much role in this as well. I don't know, you might be able to make the argument that, hey, if you're going to pay me in euros, I need a higher rate. But in my mind here, I'm thinking that's not really going to make too much of a difference. Employee residence, I'm going to go ahead and drop that one because it's going to create extra noise that we don't need. The company location is probably going to be the most important. Okay, so we're going to go ahead and drop employee residence because I'm already dealing with company location. So I'm assuming, just going to go ahead and guess that it's not going to make too much of a difference. So let's go ahead and start with dropping those features here. X equals 1. All right. So let's start with that and go ahead and train the model again here. See if we get better or worse results. My bet is that we're going to get worse results here. And I'm sure that that's where I'm all. 127,000, 25,500. That, to me, just doesn't seem right. And I know why. It's because I didn't drop these in place here. So let's go ahead and restart that. I'm leaving that in because you'll probably do the same thing at one point in your life. All right. And this is barking at me now because my categorical features, I've got some included in here that I've removed. For instance, salary currency and employee residence. All right. And then we should be able to continue on down the line. Okay, so we see some improvement in our root mean squared errors. We see some degradation in our mean absolute errors here. 54,880, which is much better than the 127,000 we were just looking at. But our mean absolute error went up significantly by about 15,000 there. And again, I think this one was benefiting a lot more from the fact that the actual salary was already in there. So I'd like to do a couple more things before we finish this up here. Is I'd like to try to train this on a specific job title, or maybe even let's just go ahead and see if we can, if maybe some certain job titles are throwing off the curve for us. So let's go back up here to where we are kind of helping out the data and see if I can't get a little bit of a better result here. We'll say select a job, and we'll go ahead and start off with data scientist, and we'll go ahead and say salaries equals salaries at salaries of job title equals selected job. Okay. And that's going to fail because at this moment right now, I don't actually have a column called job title. But if I rerun from the top, and it all goes through. All right. Mean absolute error went down a little bit. Root mean squared error, I think that is about what we were at before. So training for one specific job there doesn't seem to improve the model. I'm going to switch the job here and say, let's just look for data analysts. And we'll go ahead and restart and run all. Okay, this is much better. Data analyst, we start to get better results here. Mean absolute error of 26,000, root mean squared error of 35,000. So thinking about this, if you were to get a job offer and say, hey, based on my data here, the job offer that you've given me is $35,000 less than what I've expected. That's not great. I mean, I don't know if I'd quit, or depending on this economy, if I would, I'd probably take it anyways. But that is an argument to be made there. Let's go ahead and just for kicks, let's try for machine learning engineer. And we'll go ahead and restart and run all. See if it needs to get better. And this one, again, we're kind of getting a little bit worse results there. Mean absolute error is at about 40,000 error, while root mean squared error is about 52,000. Okay, so the last thing that we want to do here is let's actually, I've got my model trained, I've evaluated it. Now let's go ahead and use it to predict for instance, I've got a job offer. Let's try to predict against it and see how it's working. You know what? One more thing that I do want to do with this is let's go ahead and block out U.S. jobs only here. It's going to be company location. And I'll say U.S. jobs. Let's see if maybe something's getting thrown off there. But it's also going to make our next step a little bit faster. And again, we see a little bit worse performance there. Okay, so what I'm going to do now here is I'm going to create a new row for us to run against. By just creating a new row, and then we're going to run it against it and see what we would expect the salary to be here. So we'll say work year, we'll put in it's 2025, and we don't know what the salary in USD is going to be. Remote ratio, we'll say it's going to be a full-time job, or actually let's go ahead and just say it's a hybrid job. And let's put it as a senior. So it's going to be false, 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 true. And let's see, employment type. Is it going to be contract or full-time? We'll say we're looking for a full-time job. And then the job title is going to be machine learning engineer. And it is going to be in the United States. And then we'll say that the company size, let's say it's going to be a mid-size. Okay. I only wanted to run this line of code up here, so that way it was close so I could see the columns and not have to keep going back and forth. And with that, let's go ahead and try to predict it. Linear model dot predict against our row to predict, and we'll go ahead and print out the answer there. Again, I'm going to restart. I think I'm actually okay to just run it as is. Nope, I'm not. Oh, and the reason that isn't working is because it's expecting a 2D array. I just passed in one dimension, so I have to wrap that in its own array. And so for a mid-company senior machine learning engineer, my model predicts that the value should be, the salary in USD should be 223,152. Doesn't sound too bad. Okay. I will post links for some of the docs here for scikit-learn, for one hot encoding, the model train test split, metrics on measuring success of a regression model, and I'll post this GitHub repo in the links down below. Comment if you've got any ideas on how we could have improved the model. And thanks for joining. We hope to see you back.